Next, if either the output or some part of the output is returned to the input side and utilized as part of the system input, then it is known as feedback. The feedback plays an important role in order to improve the performance of the control system. Next, types of feedback. There are two types of feedback. One is positive feedback system. Next one is negative feedback system. So this one shows the block diagram of a positive feedback system. Here RS is the input signal and CS is the output signal, and this one is the G block and this one is the feedback block. This is the gain of the block diagrams, and this one is the summing point. This cross mark whenever enclosed in a circle, this one is said to be summing point, where the output input signal RS is added with the feedback signal, so it may be positive and this signal is positive. So we are getting the output is also positive. The positive feedback adds the reference input RS and feedback output S. The above figure shows the block diagram of positive feedback control system. The concept of transfer function will be discussed in later chapter. For the time being, consider the transfer function of positive feedback control system is. Next one is negative feedback. The negative feedback reduces the error between the reference input RS and system output. The following figure shows the block diagram of a negative feedback control system. See that in that case, similarly, this one is the block diagram of a negative feedback control system. Here the input is RS and output is CS, and the GS is the gain and H is the feedback from the negative side, from the output side to the summing point. Here the input is RS positive and the feedback signal will be negative, so RS plus HS will be add with the summing points, and then whenever multiply with the gain of G, then we are getting the output across the CS. The transfer function is given by T is equal to G by 1 plus G into H, where T is the transfer function or overall gain of the negative feedback control system. G is the open loop gain, which is function of frequency. H is the gain of feedback path, which is function of frequency. The derivation of the above transfer function is present in the later chapter. Next, effect of feedback. Let us now understand the effect of feedback. The effect of feedback on overall gain. From equation 2, we can say that the overall gain of negative feedback closed loop control system is the ratio of G and 1 plus G into H. So the overall gain may increase or decrease depending on the value of 1 plus GH. If the value of 1 plus GH is less than 1, then the overall gain increases. In this case, GH value is negative because the gain of the feedback path is negative. If the value of 1 plus GH is greater than 1, then the overall gain decreases. In this case, GH value is positive because the gain of feedback path is positive. In general, G and H are functions of frequency. So the feedback will increase the overall gain of the system in one frequency range and decrease in the other frequency range. Next, effect of feedback on sensitivity. The sensitivity of overall gain of negative feedback closed loop system. The control system to the variation in open loop gain is defined as to partial differentiation with respect to g on both sides of the equation 2. Del of t by del g is equal to del by del g of g by 1 plus gh. That is equal to 1 plus gh into 1 minus gh divided by 1 plus gh whole square. That is equal to 1 by 1 plus gh square. Make them equation number 5. So from equation number 2 we will get g by t is equal to 1 plus gh. Substitute these values in equation 6. In equation 4 we have the transfer function is equal to 1 by gh square whole into 1 plus gh, that is equal to 1 by 1 plus gh. So we go to the sensitivity of the overall gain of the closed loop control system. As the reciprocal of 1 plus gh, so the sensitivity may increase or decrease depending on the value of 1 plus gh. If the value of 1 plus gh is less than 1, then sensitivity increases. In this case, gh value is negative because the gain of the feedback path is negative. If the value of 1 plus gh is greater than 1, then the sensitivity decreases. In this case, gh value is positive because the gain of the feedback path is positive. In general, g and h are the function of frequencies. So the feedback will be increase the sensitivity of the system gain in one frequency range and decrease in the other frequency range. Therefore, we have to choose the value of gh in such a way that the system is sensitive and less sensitive to the parameter variations. Effect of feedback on stability. A system is said to be stable if its output is under control. Otherwise, it is said to be unstable. From equation 2, if the denominator value is 0, that is gh is equal to minus 1, then output of the control system will be infinite. So, the control system becomes unstable. Therefore, we have to properly choose the feedback in order to make the control system stable. Next, effect of feedback on noise. To know the effect of feedback on noise, let us compare the transfer function relationship with and without feedback due to noise signal alone. Consider an open loop control system with noise signal as shown below. This one is the block diagram. This is the RS is the input, GS is the one block and GB is another block n. And this one is summing point. The output is will be CS. The open loop transfer function due to noise signal alone is CS by NS is equal to GB. It is obtained by making the other output RS equal to 0. So then input is RS, this one is summing point, this is the negative, this is the feedback path, negative, GA is the gain of one block, GB is the gain of other block. This is also another summing point is here and the output is CS. The closed loop transfer function due to the noise signal alone is CS by NS is equal to GB by 1 plus GAGB into H. It is obtained by making the another input RS equal to 0. Compare equation 7 and equation 8. In the closed loop control system, the gain value noise signal is decreased by increasing the gaining values. Next, standard test signal. The standard test signals are the impulse signal, step signal, input signal, ramp signal and parabolic signal. These signals are used to make the performance of control system using time response of the output.